Okay, so we're going to talk about 3 different logarithmic properties. They're going to be kind of similar to the exponential ones that we've done. If that should kind of make sense because exponential and logarithmic functions are inverses, so they kind of go together. So our first one's called the product rule. So just like for exponents we have the product rule, we have one for logarithms too. So if I have log base b of x plus log base b of y, we can combine these by multiplying x and y. So log base b equals, log base b x times y. Okay, so let's look at an example, see why this makes sense. So first let's do one with just numbers. So let's say I have log base 2 of 8 plus log base 2 of 2. Okay, so if I were to follow the rule, that would be log base 2 of 16. Now, kind of using this kind of like a proof, simplifying what we already have done before, we know that we can rewrite 8 as 2 to the 3rd power, so that would simplify to 3. And then log base 2 of 2 would just be 1, right? So I get 4 that way. Now on the right side, log base 2 of 16 is 2 to the 4th power, so again, simplifies to 4. Okay, so I kind of just proved that that works out. It would work for anything. Let's do one more of the product rule. How about log base 2 of x plus log base 2 9 plus log base 2x. Okay, so I can multiply all those together, the x, 9, and the x. So that would be x times 9 times x, which that I can simplify that to 9x squared. So log base 2 of 9x squared. Okay, how about the next rule is going to be the quotient rule. Again, just like with exponents, we have the quotient rule. We're going to have the logarithmic quotient rule. So, log base b of x, if you can guess, instead of plus, is going to be minus log base b of y. This combines to log base b of x over y. So again, let's do one with numbers first, and then we'll do one with x's in it too. So how about let's stick to log base 2. Log base 2 of 32 minus log base 2 of 8. So using the rule, we know that this should be log base 2 of 4. 32 divided by 8, 4. So if we kind of prove this, 32 is 2 to the 5th power, so that would be 5. 8 is 2 to the 3rd power, so that would simplify to 3. 5 minus 3 is 2. How about log base 2 of 4? Log base 2 of, instead of 4, I'm going to write that as 2 squared. That also simplifies to 2. Okay, so that checks out. Okay, how about this one though? How about log base 4 of x minus log base 4 of 7. Okay, so this would simplify to log base 4 of x over 7. So it's always going to be the first one, if it's the first one minus the second one, first one on top, second one on the bottom. Okay, so last rule is the power rule. Power rule for logarithms. So what this says is that if we have log base b of x to the r power, what we can do is we multiply that r out front. So this is the same as r log base b of x. So that exponent of x can get multiplied out to the front. So again, let's kind of prove this with some numbers. How about if I had log base 2 of 2 to the, let's do 2 to the 3rd power. So that should be the same as 3 log base 2 of 2. Okay, so well, from on the left side, we know that that's just going to simplify to 3. On the right side, log base 2 of 2 is 1, so I get 3 on both sides. Okay, how about one with the next now? Let's say I want to rewrite log base 3 of x squared. Okay, this can be rewritten as 2 log base 3 of x. That would be the same thing. How about log base 5 of the square root of x? Okay, now this, let's kind of do a little rewriting first. How can we rewrite square root of x? That's the same as x to the 1/2 power. So then using the power rule, I can bring that 1/2 out front. 1/2 log base 5 x. Okay, so that would be what's considered expanding it. Okay, let's do one where we have to use a couple of the rules. One more example. So here's an example with all the rules. Okay, how about this? So we're gonna the directions might be, say, fully expand this logarithm. Log base 3 of x squared y divided by z to the 3rd power. Okay, so first let's break this apart. This would be log base 3 of x squared y and subtract the bottom, log base 3 of z cubed. Okay, so that breaks it apart, that I have the top minus the bottom. So I'm kind of going backwards here. I'm expanding it instead of putting it together. Now I could pull apart the x squared and the y by adding x squared plus log base 3y minus log base 3 of z cubed. Okay, so now one last thing, I've got some exponents. I could rewrite this with my exponents out front, multiplied out front. So I've got 2 log base 3x plus nothing to do in the next one because it's just to the 1 power, log base 3y minus 3 log base 3z. So there's one. I went the other way. I fully expanded using the rules.